things we're doing. A lot is going to be using models. So modeling the division of fractions. We did bar models and number line models. We did the bar models a little bit before, but we'll show you the number line models today. We're going to, guys, stop. We're going to compute and interpret quotients for fractions and interpret remainders in real-world problems. And we're going to divide with mixed numbers. Yes? Go quickly. You should bring your books with you, guys. Jaden? You should bring your books with you. Okay, homework tonight, very easy. One Matthew workspace. So you'll be through 9 at this point. So make sure you're on target. This one is called Interpreting Remainders Using Models. So just make sure you understand which one you're doing. So that is what we are doing. Let's go ahead and start doing it. Open up in your modules to page 50. 50. Today, we're going to do number line models. So this is another way to do it. We've been doing the area models up to now, using different rectangles to help you understand how it goes. The number line models can work relatively well, especially when the divisor is a factor of the dividend. So we'll see how this goes. Excuse me. In the model, this whole thing revolves around a number line. So everybody hopefully is good with number lines, right? The difficulty on this is, because we're working with fractions, you're only going to be, for most of them, you're going to be using the interval from 0 to 1. When we get into mixed numbers, you'll go further. But the bottom line is we're going to train you is going to be looking at this piece. A lot of this goes back to our essential math question. In a division problem, the thing you really need to be able to visualize is, what am I dividing and how many groups am I dividing it into? Okay? So understanding your dividend, your divisor, and then getting the quotient from that. Because our model is going to be based on our dividend. So in this case, we're going to use 3/4 divided by 1/4. So our dividend is 3/4. Our divisor is 1/4. When we are doing word problems especially, a very important question to ask yourself is, how am I dividing this up? The way we would read this problem is, how many 1/4 are in 3/4? That's going to help you be able to write the problem. Once I have it written, my dividend, what I'm dividing up, is what goes on top. So with my number line going from 0 to 1, right here, what I do is on the top side, I say, okay, I'm dividing up 3/4. So that goes on top of my model. On the bottom of the model, my number line is broken into intervals based on what my divisor is. Austin, it's normally better to have the book open so you can actually write down what I'm putting on the board. So in this case, because I am dividing it into 1/4, on the bottom, I'm going to now make intervals of 1/4, and I'm just going to count. There's 1, 2, 3 of them. So there are 3 1/4 in 3/4. Does that make sense so far? Yes. So key pieces. My dividend goes on top. My divisor shows me how I am breaking my number line down, and I just count until I get to my dividend. Okay? Really, really important, guys, this mathematical question. Asking yourself, how many of the divisors in the dividend? That should help you set everything else up. So at this point, let's do a, so what is the quotient, 3/4 divided by 1/4, represented by the model in the worked example? What did we say it equaled? How many 1/4 were there in 3/4? 3. That's it. So do you guys feel like you have enough background information to hit this on your own, or do you want me to do one more example with you?
We can do one more.
Raise your hand if you want one more example. Okay, that definitely looks like the majority. So we'll do one more together, and then I'll give you guys a chance to practice. So here, write a question to describe what each division expression is asking, then draw a model. So there's another task to determine the quotient, and write a sentence to describe your answer. So what we're saying, right, the question, that's this question right here, guys. How many of what are in what? So in our part A, I'm asking how many 1/8 are in 1/2. There is our mathematical question. Everybody good so far? Okay? So, having written the problem, I now know my dividend is 1/2. So between 0 and 1, where am I going to find 1/2? In the middle. So 1/2, this is my dividend. This is what I'm trying to figure out. How many of the 1/8 are in that section? How am I dividing it into 8ths? Okay? So now as I start on the bottom side of the number line, I'm going to start counting by 1/8 until I get to 1/2. So I'm going to go 1/8, 2/8, or 1/4, if you simplified, 3/8, 4/8, which would simplify to 1/2. So how many 1/8s were there? We had 1, 2, 3, 4. So how many 1/8s are in 1/2? 4. So write a sentence to describe your answer. There are 4 1/8s in 1/2. Is this making sense? Are you starting to see the pieces? Okay, hopefully it does. Now we're going to give you guys a chance to work together as a group and work out part B. We'll give you guys like 4 minutes. Again, if you go through the process on this, it's going to make it easier. So if I start with the question, how many 3/8 are in 3/4, that should help you set this up. Because what I'm asking is, I have 3/4. How many 3/8 are in it? Well, I actually saw a student in first period that did this that I thought made it make a lot more sense. He actually said, well, if I divide it into 8s, I can go up by 8. So 1, 2, 3/8. So he knew there was one section that he did 4/8, 5/8, 6/8, which is equivalent to 3/4. So he said there's 1, 2. So the answer is there are 2 3/8 in 3/4. Does that make sense?
Yeah.
Now, hopefully you guys still remember, we gave you guys a key phrase last time. Because we said, Ms. McShannon and I both admitted, we're not huge fans of the models. So who remembers the phrase that we gave you for how we do division? Liam, you remember it?
I was going to ask if you were overcomplicating this because I found an easier way of doing it. Then you're dividing by, then multiply it by then you're dividing into.
So in other words, you did what we taught you to do last time.
Yes, but it's what?
But you forgot the phrase that we used, which is what I asked for. Tita? That's not the phrase we used. Nobody?
Oh, yeah.
Say it again. You're very close. Reciprocal. Does that ring a bell? Okay, so apparently we need to say it a few more times because you guys really need to understand this concept. So, to Liam's point, are we overcomplicating this? In Miss McShannon's opinion, I feel confident talking for her. Yes, we are. But this is the way that our curriculum has asked us to teach it to you. So we're showing you these different models because there are some of you that will help it make more sense. But the bottom line is you need to understand I don't divide fractions. Instead, I multiply by the reciprocal. Okay? So I don't divide 1/2 by 1/8. Instead, I'm going to multiply by the reciprocal. Remember, to find the reciprocal, all I do is I turn the number upside down. So instead of 1/8, I now write it as 8/1. Then I just do the math. 1 times 8 is 8. 2 times 1 is 2. 8 divided by 2 is 4. So that is how we can get the answer mathematically.
My brain hurts. I don't get it.
Okay? So let's try again. Now I have 3/4 divided by 3/8. But I don't divide fractions, guys. I don't divide fractions. Instead, let's say it all together, multiply by the reciprocal. Liam, try joining us instead of messing with your paper. You ready, Liam? I don't divide fractions. Instead, I multiply by the reciprocal. Make sense? So I don't divide. Instead, I multiply by the reciprocal. So I'm going to do reductions this time, just because these numbers are going to get bigger. So if I find a common factor on top and bottom, I can reduce it out before I do the multiplication. So I see a 3 on top and a 3 on bottom. I can divide both of those by 3. 3 divided by 3 becomes 1. 3 divided by 3 becomes 1. I see a 4 and an 8. I can divide both of those by 4, correct?
Yes.
So 4 divided by 4 is 1. 8 divided by 4 is 2. Now I just multiply. 1 times 2 is 2. 1 times 1 is 1. 2 divided by 1 is 2. If you don't like to do reductions, I can just do the math. 3 times 8 is 24. 4 times 3 is 12. 24 divided by 12 is 2. Will I get to the same answer?
Yeah.
Yes. But I'm getting much bigger numbers, much more chance at making a math error. Okay? Yes?
There's an easy way to remember it. Just in case you have to change flip with the...
I'm still waiting for permission, the green flag on that. Right now, we're still going with multiply by the reciprocal. Okay, let's go to activity 2. We now have talked about the models. We've shown you the models. We now want you to create a model to represent each situation and then answer the question. I will give you a big hint in this. Read the problem, mark your text, and write the division problem out before you try to model it. So write the division problem, and if it really helps you, that mathematical question is really important. It's saying how many of what are in what. So as you read the problem, keep that question in the back of your mind to figure out how you're dividing it up. So we did find out last class this one will take a while. I wanted it done in 5 minutes. Ms. McShannon gave 15, and she was right. So we will give you 15 minutes. You may work together at the table. Go. Guys, bring it back in. So again, this whole thing starts with making sure you understand what's being broken into what. So in this case, Mason has 2/3 of a foot of ribbon. He needs to divide the ribbon into 1/6 foot pieces. How many pieces can he cut? So starting with writing your division problem should set the rest of this up to be successful. So in this case, I have 2/3, and I'm dividing it into 1/6 sections. So the mathematical question is, how many 1/6 are in 2/3? Right? That now sets my model up, because I know my model, I'm going to be between 0 and 1. I'm going 2/3. So my dividend tells me how far along I'm going. So that would be 1/3, 2/3. My divisor tells me how I'm breaking my number line up until I get there. I'm breaking my number line into 1/6. So it would be 1/6, 2/6, which is 1/3, 3/6, which would be 1/2, 4/6, which is 2/3. So how many did it take? I took 1, 2, 3, 4. So how many pieces can he cut? He can cut 4 pieces from the ribbon. Now, mathematically, how does this work mathematically? 2/3 divided by 1/6. Do I divide fractions? No, instead I multiply by the reciprocal. So I'm going to multiply by the reciprocal. I've got a reduction. I've got a 3 and a 6. I can divide both those by 3. 2 times 2 is 4. 1 times 1 is 1. My answer is 4. Make sense? Okay, number 4. Nicole placed a signpost that's 4.5 miles long. The signposts divide the trail into sections that are 3/4. How many sections does he create? So again, start by writing out the division problem. 4.5 being divided into 3/4 sections. My mathematical question to help make sure you did this right. How many 3/4 are in 4.5? Does that sound like what the question is asking? That means I wrote the problem correctly. If you rewrite the mathematical question, you're like, that doesn't make sense, that means you reversed your dividend and divisor. Now, we haven't done the mixed numbers yet, so let's just talk about that one. All I'm doing, guys, is making my number line now 4.5. So starting at 0, I'm going 1, 2, 3, 4, and halfway there. So to 4.5. That is my dividend. How am I dividing it? Into 3/4 sections. So I go 3/4, then 6/4, or 1.5, then 9/4, or 2 1/4, then 12/4, which would be 3, then 15/4, then 18/4, which would be 4.5. So how many did I do? 1, 2, 3, 4, 5, 6. So there are 6 sections. Mathematically, how do we do this? 4.5 divided by 3/4. First off, if I have mixed numbers, I need an extra step in here, don't I? So on my side, I taught you as slam dunk, right? I need to turn the mixed number into an improper fraction. So we multiply, then add. 2 times 4 is 8, plus 1 is 9. So I rewrite it, 9/2 divided by 3/4. But I do not divide fractions. What do I do, Ezekiel? What do I do? I didn't ask that, Liam. Ezekiel, what do I do if I don't divide fractions? I multiply. You have it written down if you've been doing what you're supposed to. I multiply by the reciprocal. So 9/2 times 4/3. I'm going to look for reductions. I have a factor of 2 on top and bottom. 2 divided by 2 is 1. 4 divided by 2 is 2. I have a factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So now I just multiply. 3 times 2 is 6. 1 times 1 is 1. 6. So there's my answer mathematically to verify that my model was correct. Make sense? Okay, one more model. Astor has a board at 3 1/3 feet. She needs to cut the board into 5/12. Oh, hello. 5/12-foot pieces. And how many pieces can she cut it? So again, we start by writing your division problem, 3 1/3, divided into 5/12 sections. So my mathematical question, how many 5/12 are in 3 1/3? Does that make sense, given the problem? Yep, so I did it right. So now to draw my model, it's a mixed number again. So I'm going to start at 0, go 1, 2, 3, and then 1/3. So there's what we're looking at for our dividend. Our divisor is 5/12, so it's actually even less than 1/2. So we have 5/12, then 10/12, which is going to be just less than 1, then 15/12, which is just over 1, then 20/12, not quite to 2 yet. Then we have 25/12, which is going to be just past 2, I hate when I do that. Should have been a 12. 25/12, just past 2. Then we have 30/12, which is not to 3 yet. Then we have 35/12, which is just before 3. Then I have 40/12, which is going to be 3 1/3. So how many did I end up dividing it into? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 sections of board. Mathematically, what did I do? 3 1/3 divided by 5/12. If I have a mixed number, what's the first thing I have to do?
Slam dunk.
Slam dunk. I need to make it an improper fraction. 3 times 3 is 9, plus 1 makes that 10/3. That's a 10, not a 6. 10/3 divided by 5/12. But I don't divide fractions. Instead, I multiply by the reciprocal. 10/3 times 12/5. Here's where reductions are going to save you a lot of effort. So I have a factor of 5 on top and bottom. 5 divided by 5 is 1. 10 divided by 5 is 2. I also have a factor of 3 in 3 and 12. 3 divided by 3 is 1. 12 divided by 3 is 4. 2 times 4 is 8. 1 times 1 is 1. So mathematically, I can see that my model was correct. It was 8 sections. So again, guys, everything we put on the board should be in your math modules. But if we ask for a model on the test, some people may not know what to do. Yeah, we do a test on all this stuff. Okay, we're getting ready for. Okay, next up. So we've gone through the models. Hope you're understanding. A partition model is our next one. Basically, all you're doing is the same thing as we did in the last one, but I'm still just partitioning the piece, the dividend, into how many pieces it is, and then counting how many I end up with. So if I take 4, and I drew 4 blocks, I then divide the blocks into thirds. I would simply count how many I had. Make sense? Okay. One of the keys, I'm looking at the denominator to figure out how much I'm cutting it into. My numerator tells me how many of those blocks I'm counting as one whole. So when it's 1 over a fraction of 1 over something, makes it super easy because I'm counting every one. But I could do, like, for example, 2/3 or 3/5 or 5/6. In that case, I would need 5 of those 6 to count as 1. Does that make sense?
Yes.
Okay. Of all of the division models, the partition one is probably my favorite. But quite frankly, I don't like any of the models. I would rather just do the math. It is far easier just to do the math, I think. Okay? So, what we're showing you here is an example. If I have 4 divided into 1/3 parts, 4, again, is my top part, so I show that I have 4 blocks. I'm dividing it into 1/3 blocks, so it means for every one, there's 3 blocks, right? Because 3/3 makes 1. So it means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 divided by 1/3 equals 12. Does that make sense to everybody?
Yeah.
Now, the model doesn't really change any if I divide it by 2/3. So if I do 4 divided by 2/3, literally the only difference, my model is still going to be drawn the same. You can see the whole blocks. But now it's every 2/3 is 1. So I count, there's 1, 2, 3, 4, 5, 6. So I have 6 sections of 2/3 to get to 4. Liam, please, guys, if I'm writing on the board, you should be writing in your modules. Okay? If it's on the board, you should be putting it into your module. There's a reason we're breaking this down, and I love the fact that your math books are yours. I mean, you guys can write in them anything you need to, but at the very least, you should be writing down what we're putting onto the boards so that you can keep track of this stuff and make sure you understand it by the time you get home. Okay? So is this part making sense to you? Can you see what we are doing? Dividing it into what the denominator is, thirds, and then counting how many of those until we get to our top number, our dividend. Okay? Yes, question. Which part? Do you see that I have the number 4, so I have 4 whole blocks? You understand I'm dividing it into thirds, so my denominator is a 3, right? So each of those blocks needs to be separated into thirds. Okay? Good so far? So then I said, okay, my numerator is 1/3. So every 1/3, I've gotten 1 block that I'm separating it into. So I separated it, here's a third, here's a third, here's a third. I do that. By the time I get to the end of 4, I've done that 12 times. Does that make sense? The only thing that changed on the second one is now my numerator is 2/3. So I'm still dividing it into thirds. That's what my denominator tells me. My numerator just tells me how many I need to count as 1. So now I say, okay, there's 1/3, there's 2/3, so that's 1. Then the next one, here's 1/3, here's 2/3, that's 1. I keep going until I get to 4. That means I've done it 6 times. Now you don't look as convinced. You are? Okay? So, and again, guys, I'm being honest with you. I'm not a huge models fan. I don't know who in here this is going to help. I'm hoping it's someone. But for me, I see 4 divided by 2/3. I just say, okay, make it into improper fractions. And then I multiply by the reciprocal. That gives me 12 over 2 or 6. I would rather just do the math. Okay? Yes, Austin?
I just know that 4 divided by 1/3 is the same as 4/3.
Right, I multiply by the reciprocal. That's what you just said. So you just said the same thing I did. Thank you, Austin. I'm glad that that's how you see it as well. Okay. I do want to make sure that you guys are all clear on this. Any fraction that I have, I could rewrite as a division. So A over B is the same as A divided by B. That is the exact same thing. Okay? You can also rewrite the final number sentence. 4 times 3 divided by 2 is 4 times 3 over 2 equals 6. So 4 times 3 divided by 2, this could be just rewritten as an improper fraction, 3/2. Make sense? Yes. The partitions? Yeah, that's our next exercise.
So you're going to make them draw it?
If the directions say. I'll give you guys a hint. Miss McShannon and I make our own tests. We don't like models, so are the models going to be on the test? No. You need to understand how to do the math. That's our primary concern. But again, this is a brand new curriculum. We're trying to be true to the curriculum. They are showing it in the book, so we are teaching it. Again, my hope is it's helping somebody. So let's look at our results from the number sentences. What did we see? 4 divided 1/3 was 12. And kind of what Austin was just saying, he said, well, I saw that as 4 times 3 is 12. 4 divided by 2/3 is 6. 4 times 3/2 is 6. So we're seeing that same result by multiplying by the inverse, aren't we? Good. So what we just did is we have now formalized what we've been saying since yesterday. That dividing by a fraction we don't actually do. Instead, we multiply by the inverse. So please write that right here again. Multiply by the inverse. We already did this definition, so you guys should already have that highlighted inside of your modules. The good news is we're at the point now where let's just do some math, okay? Rewrite each division sentence as a multiplication sentence and then calculate. So you've got 4 problems. Go ahead and solve them. Go. Okay, I'm going to go relatively quickly because you guys should have done this. So basically just check your work as I'm going. If you have questions afterwards, we'll talk. I will say again, this rewriting, guys, as a multiplication sentence is really critical for you to be successful, especially as our numbers get more complex. Okay? I don't mind if you have whole numbers, if you want to just do it there rather than rewriting it all as a division, but you do need to rewrite it as a multiplication. So that means I rewrite the first one stays, change it to multiplication, and then I flip the second one. I multiply by the inverse. 5 times 4 is 20 equals 20. Second one, again, whole numbers go over 1. Rewrite it as multiplication. 1 times 1 is 1. 8 times 2 is 16. Rewrite 4/5, multiply by the inverse. Nothing I can reduce, so 4 times 3 is 12. 1 times 5 is 5. 5 goes into 12 twice with 2 left over. Then our last one, rewrite. And here's another key. Do not try to do reductions until it is multiplication. I cannot reduce in a division problem. So rewrite it as multiplication. Now I don't have any reductions. Just 9 over 10. How do we do? How many got 4 out of 4 right? Good job. Almost everybody. Okay? Those of you who didn't get 4 out of 4 right, I hope you can recognize where you went wrong. If you need some extra help, please ask. Okay? Leanne?
I don't get the only one I got right was 8.
Okay, I'll come look at yours. Everybody else, I want you to go ahead and do number 3 if you haven't done it yet. So, we haven't done a whole lot of these yet. What does this mean? Means they're wrong. So we want you to analyze what did they get wrong, but more importantly, I want you to give me the right answer as well. So you have to do both. Figure out what Alexa did wrong, but then give me the right answer. Okay? Sorry. You'll get help. Guys, so who thinks they know what Alexa did wrong? Brandon? Good. What did she do instead? Good. All she did was flip the fraction piece. But in order to make a mixed number a reciprocal, my first step is I have to slam dunk. I've got to turn it into an improper fraction. So since Mrs. McShannon isn't here, you guys probably keep giving me this weird look. What are you talking about slam dunk? Here's slam dunk, guys. If I have an improper fraction, this is kind of like basketball. One of my favorite moves in basketball is what we call slam dunk. The player comes to the hoop, he has the ball, he goes really fast, and then he goes slow as he brings it in, right? It's what we do on mixed numbers. I go really fast. My fast operation is multiplication. Then I go slow, I add the numerator. So our slam dunk, I do 8 times 3 is 24 plus 5, 29. So that becomes 29 eighths. So now I've made it an improper fraction. Now I can find its reciprocal. Now I just turn it upside down. The reciprocal is 8/29. Make sense? Who said no?
I get it now. Because at first I was wondering why you flipped it, and then I remembered why we were doing this.
That's what a reciprocal is. Okay, guys, really quickly, for those of you who are still wondering, what does a reciprocal do? The definition of reciprocal is the saying, 29 over 8, what number would I multiply that by to get 1? Well, here's the beauty, and here's again why I like reductions. I have an 8 on top, 8 on bottom. Those both become 1s. I have 29 top, 29 bottom. Those both become 1s. 1 times 1 is 1. 1 over 1 is 1. That's why 29 over 8, the reciprocal is 8/29. When I multiply them, I get 1. Yes, ma'am?
You did the incorrect reciprocal.
He's saying that you did the one on the right instead of the left because they asked about the one on the left. They asked what the reciprocal of 3 and 8 fifths.
But 3 and 8 fifths shouldn't have been written that way, because if they did it, it should have been rewritten as 4 and 3 fifths. So I used the one that was written in proper form to find the reciprocal.
I'm pretty sure you're supposed to do it with the first one.
Yeah.
That's why.
No, because this first one, guys, that's not written properly. I don't write a mixed number with an improper fraction. I mean, literally everything about that is wrong.
This book makes me angry because they should have just flipped them and it would have been fine.
Yeah,
But like I understood what he was saying.
I do. And that's actually a really good point that he saw that. Now I'm curious. So that would have been 15/23 fifths.
Unless we changed it to
But then that should have been
right. But it should have been
4 and 3 fifths. So that's still 23 fifths.
right.
So that one actually would have worked. Okay, guys, we have one page left. We have problems 4, 5, and 6. You don't have to do any models. Now we just want you to solve it. Unfortunately, we have 7 minutes left in class. So I'm going to give you guys 4 minutes to solve it. I'll show you in 2, and then we'll talk about your homework in 1. Go. Okay, our first one, I've got 5 2/3, dividing it into 1 5/6. So we have to slam dunk both. Gives us 15 17/3 divided by 11/6. Now I need to multiply by the reciprocal times 6 over 11. Again, I prefer looking for reductions. It can make my math easier. I have a factor of 3 divided by 3 is 1. 6 divided by 3 is 2. Gives me 34 over 11. So that's going to go 3 with 1 left over. Okay? Number 2, 47 1/2 divided into 1 1/4 servings. Excuse me, that's going to be 94/95 divided by 5/4. Now I do my multiplying by the inverse. I have another reduction. 5 is actually going to there 19 times. Now it's just multiplying. 38. And our last one, 9 3/5 divided into 1 3/5 gives us 48 fifths divided by 8 fifths. Doing our multiplying by the inverse. Again, reductions make life way easier because those both become 1s. That's a 1 and a 6. Just 6 over 1 or 6. And obviously I would write them in full sentences, but we have 1 minute left. So your homework tonight should be really easy. All you're doing is one Matheo workspace. Okay? It is interpreting remainders using models.
How many math problems are we supposed to, like, are we, like,